Hello viewers, in today's class we are going to find out one important limit involving greatest integer function and the absolute value function, right? So here we have to find out the right hand limit of this function, and here we have to find out the left hand limit of this function, right? So here the function is given as f of x is equal to greatest integer x divided by uh, absolute value of x, right? So let us start. So here in the first case we have to find the right hand limit of this function at x equal to 1, right? So we have limit x tends to 1 plus, here we are denoting this positive sign for right hand limit, and here we have greatest integer x over absolute value of x, right? So let us substitute x is equal to 1 plus h, right, where h is a very small quantity and h is greater than 0, right? So when x tends to 1, then h tends to 0, right? So if we substitute x equal to 1 plus h over here, then the right hand limit is equal to limit h tends to 0, and here we have greatest integer 1 plus h divided by absolute value of 1 plus h, right? Okay, now here we see that this parameter h is greater than 0, right? But h is a very small quantity, right? So 1 plus h is always greater than 1, or in other words we can say that 1 plus h is slightly greater than 1, right? So here we have to use the definition of greatest integer function, which says that the greatest integer 1 plus h is equal to 1, right? Because suppose if we take h is equal to say 0.01, right, h being a positive number and very small, so let us take for instance h is equal to 0.01, or you may take 0.0001, right? So here we'll prefer h equal to 0.01. So the value of 1 plus h is equal to 1 plus 0.01, that is equal to 1.01, right? So now the value of greatest integer 1.01 is equal to 1, right? Okay, so the value of greatest integer 1 plus h is simply 1, and here we have the absolute value of 1 plus h, right? Now when h tends to 0, we have 1 over mod of 1 plus 0, that is equal to 1 over mod of 1, that is equal to 1 over 1, that is 1, right? So the right hand limit of this function when x tends to 1 is 1, right? So now let us evaluate the left hand limit. Now the left hand limit of this function f of x is given by limit x tends to 1. Here we'll have a negative sign to denote the left hand limit, and here we have greatest integer x divided by absolute value of x, right? So in order to evaluate this limit, let us put x equal to 1 minus h, and as we have discussed, h is a positive quantity, but h is a very small number, right? So when x tends to 1, then h tends to 0, right? So therefore the left hand limit is equal to limit h tends to 0, and here we have greatest integer 1 minus h, and divided by absolute value of 1 minus h, right? So now here also we'll make use of the definition of greatest integer function, and if we take h equal to 0.01, then the value of 1 minus h is equal to 1 minus 0.01, and 1 minus 0.01 is equal to 0.99, right? So the greatest integer 1 minus h is equal to greatest integer 0.99, and by definition of greatest integer function, the value of greatest integer 0.99 is 0, right? So here the left hand limit is h tends to 0, and here we have the value of greatest integer 1 minus h is 0, divided by say 1 minus h, right? So this is equal to 0, right? So here we have taken h equal to 0.01 as a special case. So the left hand limit of this function is 0, right? So the left hand limit is equal to 0, and we have just calculated the right hand limit, which is equal to 1. So we see that the right hand limit and the left hand limit are not equal, right? So we conclude that the limit of this function at x tends to 1 does not exist, right? Does not exist. So viewers, this is how we calculate the right hand limit and the left hand limit of this function, which is a quotient of greatest integer x and absolute value of x, right?